Welcome, I'm so thrilled you're here. If you're building LLM applications right now, well, you already know this space is moving at absolute lightning speed. So today, in this explainer, we're going to cut right through all that marketing noise. We're looking at hard data to help you choose the exact right LLM architecture for your project. The goal? To get you the capabilities you actually need without over-engineering the whole thing, and definitely without those late-night debugging nightmares. So here is our game plan for this explainer. 1. The architectural crossroads. 2. LangChain, the orchestration layer. 3. LlamaIndex, the retrieval layer. 4. Raw APIs, the minimal path. 5. The head-to-head comparison. And finally, number 6, building the layered stack. It's going to be a bit of a battleground comparison, so let's get into it.
Okay, let's dive into this. Section 1, the architectural crossroads.
Picture this. Everything usually starts out totally fine. You've got a working prompt, the model is giving you great answers, life is good. But then, the requirements expand. Suddenly, you're faced with this massive question. What happens when a single prompt just isn't enough anymore? Maybe your model needs memory to remember a chat from 3 messages ago. Maybe it needs retrieval to dig through your company's internal wiki. Or maybe it needs tools to actually go out and take action, like pinging a database. You are officially standing at a pivotal architectural crossroads. And I've got to warn you, choosing the wrong framework right now, it might not break your prototype today, but it will absolutely break your production system 6 months down the line. We're talking deep stack traces, bloated costs, and just a massive headache for your engineering team. And hey, speaking of bloated costs, just take a look at this staggering number. Between late 2024 and mid-2025, LLM API spend doubled, hitting $8.4 billion. I mean, that's enough to make any CFO sweat, right? These are real production budgets on the line. The framework you choose, that layer of code sitting right between your app and the model, directly determines how much of that massive budget pays for actually useful work versus how much is completely wasted on unnecessary abstraction. Let's move on to section 2, LangChain, the orchestration layer. All right, let's strip away the hype for a second. Fundamentally, LangChain is a general-purpose orchestration framework. It's built for chaining LLM operations together. Started back in October 2022, it has seen incredible adoption. We're talking over 119,000 GitHub stars. Its whole core philosophy is about standardizing multi-step workflows. If you need to snap together prompt templates, model calls, memory, and tools, LangChain gives you a very uniform way to do exactly that. It's like a giant set of Legos for AI. Now, its core superpower, it truly shines when assembling complexity. It is fantastic at orchestrating multi-step agents and persisting stateful memory. Specifically, if you look at LangGraph, it models agent workflows as directed graphs. It has this incredible ability to literally pause and persist an agent state via checkpointers directly to databases like SQLite, Postgres, or Redis, meaning your agent can pause mid-thought and just resume hours later. That is a genuinely difficult feature to build yourself from scratch. So the crucial point is, what does this orchestration abstraction actually cost you? Because while LangChain offers this beautifully consistent LCS scale interface, the trade-offs are very, very real. You're looking at a latency tax of about 10 to 14 milliseconds of framework overhead per step. There's a massive token overhead, roughly 2.4K tokens per query just to keep the framework humming. And when things break, you are routinely facing deep stack traces spanning 15 to 40 frames of internal code. It makes debugging an absolute nightmare. Plus, for just a simple retrieval pipeline, LangChain can require 30 to 40% more code and lead to 2.7 times higher token costs compared to a native setup. Let's pivot to section 3, LlamaIndex, the retrieval layer. Now, this is our second contender, and it's a highly specialized tool. LlamaIndex is purpose-built from the ground up to help LLMs reason over your own external data. Where LangChain is all about orchestrating the steps, LlamaIndex's entire design is completely organized around the data itself. We're talking ingestion, chunking, embedding, indexing, and hyper-accurate retrieval. Its core superpower lies right there in its out-of-the-box advantages. We are talking blazing fast document ingestion, hierarchical chunking that actually preserves the parent-child relationships between sections, and incredibly accurate retrieval. I mean, it handles chunking and indexing often in a single, simple call, and it's backed up by over 300 pre-built data connectors through LlamaHub. You can plug into Notion, Google Drive, PDFs, SQL databases, you name it, all without writing a single line of custom integration code. Let's look at the hard data on performance here.
LlamaIndex indexes documents 2.5 times faster than LangChain. It hits sub 200 millisecond query latency for 10,000 documents. It has a much lower framework overhead sitting at just about 6 milliseconds and a lower token usage of roughly 1.6K tokens per query. Basically, you get way more retrieval quality with far less assembly. However, to be totally fair, it does have weaker out-of-the-box multi-turn agent state persistence compared to LangGraph, so you're going to have to do a bit more manual work if you need stateful, long-running agents with a human in the loop.
Moving right along to Section 4, Raw APIs, the minimal path.
This brings us to a really surprising trend we've been tracking for 2026. Teams are quietly migrating completely away from frameworks and going straight back to raw APIs. And by that, I mean using provider SDKs like OpenAI or Anthropic directly, with absolutely no extra orchestration layer in the middle. And listen, this isn't some primitive fallback. It is a deliberate, calculated stance on minimizing abstraction to maximize your speed and clarity. The core superpower here? Ultimate transparency. Zero framework overhead. Direct access to native features. You see, by 2026, things like natively supported tool calling, streaming, and multi-turn memory, they're just baked right into the vendor SDKs, which means frameworks often just hide clarity rather than complexity. When you use the raw API, you are engaging directly with the most optimized path to that model. And this brilliantly illustrates the point. Look at the reality of debugging production errors. With a raw API, you've got a direct small stack trace, maybe 2 to 5 frames. But with LangChain, you're staring down a deep, hidden stack of 15 to 40 frames. When something breaks in an 80-line raw Python loop, you have total transparency. You know exactly where to look, you fix it, and you move on.
Okay, time for the climax. Section 5, the head-to-head comparison.
Let's start with the latency tax. As you can see, raw APIs have effectively zero framework overhead. LlamaIndex sits around a very manageable 6 milliseconds, and LangGraph is up there at 14 milliseconds. Now, I know what you're thinking. 14 milliseconds doesn't matter for one single human chat interaction. But if you are building high-throughput, latency-sensitive pipelines processing thousands of requests, that overhead compounds massively. Next up is the token overhead per query, and wow, the contrast here is stark. Raw APIs, zero extra tokens. LlamaIndex uses about 1.6K tokens, while LangChain uses roughly 2.4K. This perfectly shows how abstraction literally eats into your production budget. For retrieval tasks, LlamaIndex has a clear 33% advantage over LangChain. That translates to serious real-world dollars saved at scale. Now, what's really interesting about this slide is seeing exactly how each tool fails in production, because a framework's value depends entirely on whether it's hiding complexity you actually face. If a prompt's change breaks your output, raw APIs and LlamaIndex make that failure immediate and obvious. But in LangChain, it might propagate completely silently through your chain. Debugging is direct with raw APIs, moderate with LlamaIndex, and deep and hard to isolate in LangChain. And for scaling throughput, raw API is optimal, while that framework overhead we talked about can quickly become your main bottleneck.
Which brings us to our resolution. Section 6, building the layered stack.
So, how are successful production teams actually building their systems today? They're using a layered stack methodology. The big secret here is that these tools are not mutually exclusive. They actually compose beautifully together when applied right. Step 1. Start with raw SDKs for simple, one-off calls where transparency and speed are key. Step 2. Layer in LlamaIndex specifically when you need document retrieval at scale. Its chunking and querying are just unmatched. Step 3. Add LangGraph only when you absolutely need stateful, multi-step agent loops that require pausing or complex memory. And that leads us to the absolute golden rule of LLM architecture. Start with the minimal option and add a framework when you hit a problem it was built to solve. Never ever pay the maintenance overhead for a future problem that hasn't arrived yet. Got a retrieval problem? Add LlamaIndex. Got a crazy state management problem? Add LangGraph. Just don't add either before you actually feel the pain they were designed to fix. So I want to leave you with this final provocative thought. What specific problem is your LLM app actually trying to solve today? I highly challenge you to ruthlessly audit your current architecture. Strip away all the marketing hype, look at the hard data, and apply this pragmatic framework to your very next sprint. Thank you so much for joining me on this explainer. Happy building, and I'll catch you next time.